Ah, yes, look at this, our first demonstration. So come on, let's move out to our host operating system. We're going to be taking a look at our Vagrant file and editing the Vagrant file to support our nested virtual machines and 4 gig of RAM. Once we then fired up our virtual machine, we'll be firing up Ubuntu 2. Remember, we only need Ubuntu 2. And we're going to check then that we do support virtual machines inside of our Ubuntu 2 system. Come on, let's dive out to the command line. And look at this, a glorious command line. Not so much a Linux command line, but the command line of my macOS host system. I'm working in the LFCS directory, and this is just a subdirectory, the way I organize my Vagrant files. We can always go through and use pwd to check our working directory. I'm inside of my home directory. Vagrant then organizes all of my projects, and obviously we're working on the LFCS, so that's the subdirectory that I've got. Now, mainly we're interested in the Vagrant file with an uppercase V, and this then is the configuration of our virtual machines. It's this file that we need to look at modifying. I'm just going to create a copy of this so we can copy the Vagrant file to vagrantfile.old. So this is a Vagrant file that we are now going to edit, the original Vagrant file. This supports 2 virtual machines at the moment, and we only need our 1 virtual machine, and we need to make some configuration changes. But when we look at the configuration that we've got, I don't need anything for Ubuntu 1, so I'm going to delete the block for the Ubuntu 1. We're only going to be working with Ubuntu 2. When we look at how much memory I need for my virtual machine, I'm going to change it from 2 gig through to 4 gig. Obviously, we want to support our virtual machines, so I'm going to put 4096. But we also need to put a new configuration option in to support the nested virtualization. Nested virtualization, or virtualization in itself, is normally a CPU setting that we would configure within the BIOS. And really, this is then going to be an option that we're going to pass through to our VirtualBox hypervisor. I'm using V. V in this case is just representing the virtual machine block that I am in. So V is just the letter of the block of code that I'm working in. Now I'm going to run v.customize. The customization is going to be down to the hypervisor we are using, and this is just a setting that we need to configure for VirtualBox. So we can specify modify VM, close off our quotes, and with the setting made, we're able then to go through and set up a list, so comma separate. We're going to have colon and ID, and again a comma after this item. We can go through and put the option that we want, so minus nested dash hardware HW dash vert, close off our quotes, add a comma. And obviously we've got to specify whether we want this turned on or turned off. Now the hardware virtualization that we're looking at here is supported after VirtualBox 6.1. So just make sure you've got an up-to-date version of VirtualBox. Comma and on inside of quotes, and then close off our list by the closing square brackets. Now this is our customization done. Our VirtualBox Vagrant file is ready to go now. So we can hit escape, colon and X, or obviously however you're editing that Vagrant file. But that Vagrant file is also going to be available to you through the Git repository, and we'll show you that once we've got our virtual machine up and running. We can fire the virtual machine up with the Vagrant up command. It looks at our Vagrant file, and it knows then to define the Ubuntu 2 virtual machine by cloning our Ubuntu image. And this is all running in real time. One of the reasons why I like to use Vagrant for these courses is it's so simple to get a system up and running. And obviously with Vagrant and VirtualBox being free on pretty much each operating system, it's very easy to get it up and running. And look how quick it's been getting it started on my system. I can just then specify Vagrant SSH to connect into the system. I don't need to use a virtual machine name now because I've only got one virtual machine. So this then takes me into the Ubuntu 2 system, so we are up and running. But of course, we want to check that we have got support for KVM nested virtualization. So we're going to make sure our metadata is up to date, so sudo apt update. So just our standard Ubuntu metadata for packaging. We can clear off our screen, so just Control and L, and then install the package CPU-checker. Now this is a very small package, so not a huge amount needs to be added in, but once that's gone, we can run the command sudo and kvm-ok. Now it tells me then that we can find the correct device file and that KVM acceleration can be used. So we're good to go with our virtual machines. But we can also look at some of the basics of Linux here. If we use the file command, we can interrogate the executable to see what type of file it is. And it tells me that it's an ordinary shell script. So we can page through and see what's been done. So less and escape and dot will bring up that last argument. And then we can just page through. First thing it does is checking that we are actually running as root. And then we have a case statement. And we can see with a case statement, it's really looking at flags from our proc/CPU info. And we can see we're looking for the VMX and SVM flags. Now, I do know this is just a shell script, but this is the whole idea of open source programming, is you can see what other people do and you can learn from their coding examples. But there we go. We know we are up and running with our nested virtualization, but we also want to check on how you can get the course materials. If we go through and just take a look at this, I know I'm doing this inside of the virtual machine, but we could do this on your host operating system, or we could go through and do it in our virtual machine. You can also access GitHub through the web. But if I go through and use git clone, and then look at github.com, the Urban Penguin, and the LFCS repository, it will create a local directory called LFCS. And if I then go through and say, look inside of the LFCS directory, we've got a directory called VMS for our virtual machines and Vagrant file. And we can see then the Vagrant file that we are working with. So we might as well use some of the technology that's available in the course to distribute our files that are needed for these courses.